Hi folks, Mr. Long here. We are going to do a screencast today on domain and range. And so let's get started. So what we want to do, folks, and there may be two parts. So the big concept today is this whole idea here of domain and range. And so today you're going to learn about what domain and range is, and we're going to apply it in a real-life situation, in a series of real-life situations. So let's talk about a ball when it gets thrown up in the air. So, you know, when I stand at the front of the class and I take a ball and I throw it up in the air and then it comes down, right? So let's take a look at that and see if we can relate it to this concept called domain and range. And really, oh, by the way, anytime you want to pause it, take down some notes, rewind it, you should really do that. So let's look at what it means. So we've got this whole idea of domain, and here's what it is. It's real simple. Domain related to mathematics refers to the x values that you're allowed to have in a table, in a graph, in an equation. So what are the x values that are allowed? So what x values are allowed along the x-axis? Range refers to the y values. Okay, the y values. Whoops, that was number 12 there. So in this case, we get a ball thrown up in the air, and let's see. So it's thrown up in the air at 0 seconds. So right here, okay, there's your y-intercept. The ball goes up in the air. I'm doing sort of time-lapse photography. And then here is where it's at the top of its throw right there, right? And then the ball starts to come down. So now it's, oh, whoops, wrong way. It's coming down on this side because it went up over here. And the ball comes down and eventually hits the ground, right? So take a look at that. The ball is released from the person's hand right there at 0 seconds. Maybe it was, in this case, it looks like it was about 6 meters in the air, 7 meters in the air. Pretty sure there's no one that tall, or they're even if they reach up high, it's not that tall. So maybe they were, I don't know, on a ladder when they threw the ball. So the whole idea then again is the ball gets thrown, it reaches a maximum height, and it comes back down to earth under the force of gravity, and it hits the ground after 4 seconds. Oh, and the highest point it reached was 12 meters in the air. Okay. So, and then what's this whole domain and range stuff? Well, domain refers to the x values that you're allowed to have, and the range refers to the y values you're allowed to have. So there's your definition right there of domain and range for now. We will make things more formal as we move along. And the other thing that I've done is, hopefully you have this, I've sent out a PDF of this document. So you can just have a copy. Okay, so, oh, by the way, let's go back to this one. So really, if you want to think about it, the domain in this case, so the domain in this case is really from 0 to 4 seconds, because you can't have negative time, right? There's no such thing as negative time in this scenario. And once it hits the ground, the ball stops moving. So it's not like it goes through the floor, right? So 0 to 4 seconds is your domain. And then your range represents what heights are you allowed to have? Well, the least value of height is, when it hits the ground, that's 0 meters. And then its highest point, or its greatest value, is 12. So 0 to 12 meters in the air. And that would be the range. Okay, we're going to add a whole bunch of notation later on. So if I go to here, here's an example. If I think about how people grow over time, right? In terms of being born, how long is a baby when a baby is born? It'd be something like up to 45 centimeters or something, which is about 1.5 feet, a little more than 1.5 feet. So let's say on average, someone is 1.7 feet tall when they're born at 0 years. We know that they grow right up until about age, boys can grow up to age 20. Girls are a little bit younger than that. And after that, they pretty much flatten out, right? You're not getting a lot of growth after age 20. So if I was to look at this, and I was to say, okay, here's a relationship. Oh, whoops, and then the maximum height is, on average, is about 6 feet, we'll say, for men. So it sort of plateaus at 6 and doesn't get any taller, right? So, and they start out at average 1.7. So domain are the X values that are allowed. Well, in this, if it's people's age, well, I think the oldest person, well, if this is, oh wait, this is averages. Let's assume this is an average graph, okay? This is an average age, average person rather. So what is the height of an average person? What is the age of an average person, etc. So the average person, or male in Canada, would live to about 76. The average females, I think, over 80 maybe. And that's just ballpark. So let's say the domain then, what is the values that are allowed? Well, you can't be younger than 0 years, right? That's simply not impossible. And then on average, we'll say the average person can live to 80 years. So you've got your domain. Then your range is the Y values that you're allowed to have. And if these are averages, we can say that maybe the average birth length of a child is 1.7 feet. And then on average, the maximum height on average is 6 feet. We recognize there's many people taller than that and many people shorter, but on average we'll say 6 feet. So that would be domain and range. All right, let's talk about notation, a little bit more formalized. And I think this is about notation. I think a neat thing we can do here is to take a look at a number line, which we're going to use to describe the ages when you are not allowed to drive a car. Well, if you think about this, when are you not allowed to drive a car? Clearly when you're born. And a number line to describe this would go between 0 and 16. But then we have to decide which numbers are allowed and are not allowed. Well, if the solution set for this are the ages that you are not allowed to drive, well, you're definitely not allowed to drive when you're 0 years old, the day you're born. But you are allowed to drive when you're 16, which is kind of weird. So my number line goes to 16. Does it include 16? Theoretically, it doesn't. You're allowed to drive as soon as you turn 16 and 1 minute on the date of your birthday. So really what it is so you can't drive if you're anything less than 16. So theoretically, if you're 15.9999999 years, you cannot drive. So here's our notation for this. An open circle like this means the number is not included in the set. So it does not include an open circle. So in this case, but a closed circle does include the value. So you're allowed to be 0 years old in this solution set. So remember, this solution set is the ages where you cannot drive. And then you've got at 16, it's an open circle because you can't include 16. At 16, you can drive. Okay, so this whole idea of open circle, closed circle. Closed circle means the number is included. Open circle means the number is not included. And then another way to write it, if you have a closed circle, you write a square bracket. If you have an open circle like this, it's a round bracket. Okay, square and round. So if we went back up to our scenario, up to age 16, that's what it would be. So these are the ages you're not allowed to drive. So you're not allowed to drive right on age 0 or at age 0, and then all the way up to 15.999999999, which really is from 0 to 16, including 0, because it's a square bracket, but not including 16. Okay. So just a couple of graphical examples, and then I'll pause this one and we'll do a video example, or an algebraic example. So here's a pool being drained, folks. So you pull the plug